Hello, my name is Kelsey, and this is MEC 442 Challenge 2 PACs. And this is my second attempt at a video. First one I took was too long, so hopefully I can condense this a little bit, but still hitting all of the deliverables on this. So here we go. So in this presentation, I'll kind of go over challenge 2. So I kind of built directly off of challenge 1, so that was just kind of my interpretation of the challenge. So while challenge 1 utilized a single PAC, challenge 2 utilizes multiple PAC controllers. So for the sake of this recording, obviously the hardware is not available, so this demonstration is just going to focus on the software architecture, state machine design, the PAC communications, and then just successfully building it in CodeSys and then building it out cleanly, so without errors, without warnings, without errors, without warnings, and then messages are okay. So we'll start with just kind of file location stuff. So this is challenge 2. These are kind of my files here. So I've got my code and then I've got all my necessary stuff. I won't go through each document, but I'll go over the important ones. So obviously this is my deployment map, or my deployment plan, technical data package. So kind of covers the whole system, kind of my concept, everything you need to know should be in this document. A couple of things to highlight are the system maps on here. So we've got the network PAC system map, and then we also have the HMI system map. So we'll kind of go into this system map. So there we go. So this is system map. So as you can see, PAC1 manages material processing operations, including the SAW and the buffers. And then PAC2 supervises CNC1 and Robot 1. And then PAC3 is CNC2 and Robot 2. So rather than allowing controllers to directly manipulate each other's internal variables, the communication occurs through the network interfaces. We'll go over HMI system map next. That's this one right here. So the HMI provides a centralized operator interface for the PAC system. So operators can initiate operation, request system startup, acknowledge, reset, and monitor status. The HMI does not directly control the machine behavior, so instead it just issues like high-level commands, which are then interpreted by the appropriate PAC. So I'm kind of working out of 2 computers here, so this is kind of more or less most of the completed documentation. Other things were just kind of tag tables and kind of other various kind of resources for the project. So we'll kind of shift, and then my computer just went down. So we'll shift over to the CodeSys stuff. So here is my CodeSys. We've got challenge 2 up at the top. So obviously you see kind of a very large project tree here. So again, I kind of took challenge 1 and then just built on top of it. So this is all my challenge 1 stuff, but then it includes all my challenge 2 stuff. So we've got global variables here, and then function blocks, main program, all the good stuff. So we got DUTs, everything there. So enumerations, so these ones, they just define the state machine behavior and standardize kind of fault classifications throughout. So if we go through them, we could go through each of these if you want, but we'll just kind of spot go through them here. Here, good there. And then PAC structure, so global variables for my PAC1, PAC2, PAC3, right here. So each PAC maintains its own state information, readiness status, production metrics, and fault information. So maintaining separate ownership of the data improves just future scalability. And then function block stuff down below here. So PAC-1 supervises material processing, cell operation, inventory management. PAC-2 and 3 supervise their CNC and robot cells, coordinating the material requests, readiness checks, production cycles, completion reporting. And then network coordinator monitors the network health, while the fault manager centralizes like ownership and reporting. And then we've got the PLC program down here. So we've got it up here and then all the way down there. So this serves as the execution layer for the distributed architecture. So each scan cycle executes PAC-1, PAC-2, PAC-3, the network coordinator, and the fault manager, which just ensures kind of good operation and coordination. And then with that, since there is no hardware, we'll just kind of go through simulation and going online with it. So we're currently in simulation, so that's good. We can just build it just to be sure. Shouldn't be good, clean build, that's good. And then we'll go ahead and we'll go online with it. Do we want to create? Yes, we do. And here we are. We are online in simulation, but obviously we can't truly test it because we're not don't have any physical hardware yet. So thank you, challenge 2.